this thing on now? I've been working long like a marathon now. Tying up words, making them a ball now. Tell me, who turned on the alarm now? I got a message, we didn't put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We're feeling inside, yeah. We're touching the lightning, we're coming alive, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a ball now. Tell me, who turned on the alarm now? I got a message, we didn't put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a ball now. Tell me, who turned on the alarm now? I got a message, we didn't put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a ball now. Tell me, who turned on the alarm now? I got a message, we didn't put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. We got the power. Yeah. is this thing on now? I've been working long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message, we didn't put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We're feeling inside, yeah. We're touching the lightning, we're coming alive, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message, we didn't put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah.
Hey folks, welcome back again. We're on to day 4. Yeah, day 4 of these sessions. We're handling the Unreal Engine Short Film Challenge Australia. So welcome everybody. If you don't know me, my name's Chris Murphy. I handle Australia, New Zealand and Southeast Asian evangelism for Unreal Engine. And on the line as well, we also have Tony Reed and Alex Stevens. Who will be helping with any questions along the way. We have the chat running, so if any folks are asking questions and whatnot in the YouTube chat, those two will be kind of leaping into Anthony and answering anything that you may ask. Tony's more likely to discuss anything regarding competition rules and that kind of thing, while Alex will be answering questions that are on a more technical level. Alex, however, is hidden behind the fancy Unreal Engine name tag, so that's who you're chatting to when that pops up. Now, tonight I'm going to be discussing visual effects in Unreal Engine, and we're just doing a basic primer. I'm going to do an intro, run through some basics, and then I'll build a couple of advanced effects. Now, I'm going to be really upfront that you're going to be in a slightly awkward position compared to where I would honestly like everybody to be. And that's because for a long time, Unreal Engine has had a system inside of it called Cascade. And Cascade was really powerful. You know, it was really good for a lot of effects. You could really easily leverage it from artists, that kind of thing. People were generally fans of Cascade. However, what's happened is we've been developing a new visual effects system, which is good. And that's called Niagara. And Niagara is it's a pretty substantial system, and it can do some really powerful stuff. But the trick we have is that as much as my heart desires to exclusively go through Niagara tonight and be like, here is all the cool stuff, and forget about Cascade. The problem we have is that if any of you are going to be leveraging marketplace assets, for your project, unfortunately, you're probably going to be going through files that may have been there for a year, 2 years, 3 years, 4 years, and that's not just from like other users. That's also Epic's content, right? You know, if you're pulling assets from Paragon or something like that, those were done in Cascade because Cascade was all that existed at the time. So if I would, I just want to be upfront about the situation. If I was teaching this in such a way that you were going to be developing your own projects 100% from scratch, and I knew that you weren't leveraging other materials, I would probably do this session just Niagara. But for today, I'm going to be just at least walking you through some of the logic behind a Cascade system and how it works, so that if you pull these things down from the marketplace to use during the creation of your shots, that you're not going to be sitting there being like, this is not what Chris showed me, and judging me accordingly. So let's flick over to a screen now, and like I said, I'm going to begin with some Cascade. So hopefully that wasn't too much doom and or gloom. So what I've actually got open here for us to start off with is the Unreal Engine content examples. Now, the Unreal Engine content examples are available in the Learn tab of your launcher. This is as far as I'm concerned, the most valuable resource that you can get from that. And anyone that's developing with Unreal would do well to have this installed on their machine, because the Unreal Engine content examples are a breakdown of like feature after feature after feature in the engine. And they you know, you can kind of get an idea of how all of these things are tied together. You can look at certain concepts in smaller bite-sized way, and that'll hopefully give you a better understanding. And obviously it depends on how you learn best, but I know for a fact that I learn best by ripping things apart and breaking them and then trying to figure out how I broke them and then putting them back together again. It's a very specific thing, works well. But this room that I have open now is if you open up the content examples and go to browse maps, you'll see that we have a bunch here, and the one called effects is a little bit of a misnomer, because in reality the one called effects is really cascade effects, while the one called Niagara is Niagara effects. But I can understand why some folks may be confused by that when they're coming in. So as I said, I've opened up the effects map, and here we can easily do just a quick tour around just some of the kinds of effects that could be created inside of Cascade. So I'm stepping through things, taking a look around. Oh, it looks like, interestingly, it looks like a couple of effects may have broken, and I suspect it could be due to streaming. Just in case, I'm going to reopen the level just to see if that was... Nope, they're all working now. Let's just back away slowly and acknowledge that that's fine. Cool. So we can see all sorts of effects, how they're put together, the kinds of things you can do, and like the general kind of logic that we have going on. If I was to hit simulate, there's extra stuff going on, like in this case, this person is on fire. Over here we have sound and light being triggered by this. And over here we can see some other cool stuff such as particle shadow casting from these lights, where we get this nice kind of slightly more volumetric effect. Again. So we can see there's quite a lot here, and this is the Cascade room. Okay, so we're going to be just analyzing a couple of these effects. I'm not really going to bother building any of these effects, like any of the Cascade ones, because it's important to me that you know how Cascade stuff is put together. But honestly, it's not really that important to me that you know how to build those effects. Okay, so if I was to look at the Niagara room, just to give you a point of comparison of what some of the things are, it's worth noting that because Niagara is quite new, we don't have as many out of the box, just cool effects to really be demoing inside of this area. But if you were to load up the Niagara room, you would see some very basic effects, just demonstrating on a conceptual level the kind of things that you can do. So they're not as pretty out of the gate necessarily in this first room, but they will show you how to achieve certain ideas and concepts. So, but that said, when you do go toward the end of this space, you'll see some of the more advanced stuff. My personal favorite is this one, which is a character being recreated out of particles and then ripped apart by other particles. So there is still some kind of cool stuff that's going on inside of these, and you can examine these as you see fit as you go through. And hopefully they can kind of act as learning examples for you. But as I said, this is the Niagara room, and for the time being, I'm just going to take a look at a couple of the effects that are inside of the Cascade room. It's worth noting as well, to be honest, I haven't actually touched Cascade in quite a while. The last time I had Cascade like for actual use was definitely pre-Niagara, so at least a year or so since I've really used it, maybe a year and a half. Cool. Someone said, silly question. Oh yeah, so to go full screen, F11 will do this. If you actually have a start menu on screen, not start menu, a taskbar on screen, you can hit Shift F11 and it will actually hide everything and go full screen, which is great. Someone asked which project this is. This is the one called Content Examples, and it's available in the Learn tab of your launcher. So let's have a look at some of the effects that are going on. I'm going to initially take a look at this GPU effects. So we're going to pull this up here. Now we've got two emitters that are actually at play here, and by clicking this button over here in Template, I can find it in the content browser and open it myself. Now, when we examine this, we can see two things going on. We have one emitter, which is CPU particles, and another emitter that is GPU particles. This is purely to demonstrate that you can do both, and you can see here that the actual structures are exactly the same. These settings are all the same, with the only difference between these two being this spawn rate. So if I was to open this up and look, I can see that this CPU particles is spawning 100 particles per second. However, if I click here, I can see we're spawning 2000 GPU particles per second. Okay. Now this is useful. You know, I can examine how this is structured, and if I wanted to, I could crank some of these values up. So let's open this up. Oh, sorry, I hit open on the blueprint by accident. By the way, a little shortcut that I haven't actually told anyone yet that I forgot about is when you select something like this, if you want to open the asset that you've got selected, you can just hit Control E, okay? And Control E will just open that in its respective editor. Just think of it as E is for edit, okay? So someone's asked, what is the difference between CPU and GPU? So your machine has different ways that we can calculate particle information. Now, if we look at CPU means it's going through your main processor, and that can generally handle way fewer particles than GPU can. However, it's also able to do certain things that a GPU particle can't. Oh, sorry, someone has said, can you remind us what your CPU and GPU are in terms of my processor? I can't remember what my CPU is, but my GPU is, I think, a 1070. Sorry about that, folks. I misunderstood the question. Anyway, once we're inside of this, if we want to look at just one of these emitters, we can hit this S button, and that will only show me that. Now, essentially how Cascade works is there is a stack. So it will do this, and then this, and then this, and it will make its way down the stack, okay? Now, this means that the spawn rate, for instance, you know, I can get on this and I can tweak this up and change this as I see fit. And I can set any of these other values along the way as well. For instance, I could look at the initial color, and I can see that this initial color is set to 20, 30, 40. And if I wanted to change the color of this to red, I could crank that up to say 90, drop this back, and drop this back as appropriate. Now, it's worth noting that for an effect like this, at any point, if we wanted to, we can also handle some of these things as a graph. So if I wanted to, instead of doing initial color, I could just right-click and add other nodes. For instance, a color over live node. Someone asked if I'm running a Ryzen processor. No, I'm definitely not. So I've got this set up, and I'm now doing a scale color over life. And if I was to get a scale color over life, I can actually set the values on this as a curve. And I can access any of the curve values here and say, hey, I want to scale this from 0, 0, 0 up to a value of 1 over the course of your life. And a useful thing that you can do is you can click here to scale that as well through a curve editor. So if I wanted to, I could add this here, and I could actually handle, oops, I'm so used to the newer curve editor. I could actually handle this as a curve, change anything I needed to, and shift it around as required, okay? Now, when we're working with this kind of stuff, as I said, when it comes to Cascade particles, the most important thing I have is that you generally have an understanding of how things are set up, and just the fact that this is a node stack. You're not going to be too uncomfortable when you open these things up. But like I said, I don't want to stick with this one for too much. So I'm going to skip through to a couple of effects to just in case, make sure that you know what you're looking at with some of these emitters. So if we move along, the next thing that I would like to look at is over here. You can see that we have GPU particles with collision. So if I was to examine this, I can see that the reason that the collision is happening is because over here we have a collision node. And the collision node just sets up all the properties of how to handle it based on what would happen if something collided. Okay, so this is reasonably straightforward but I just want you to be aware that these kinds of nodes exist. And if it's a GPU emitter, it's worth noting that you're going to have your collision generally happening off of scene depth. And if it's happening off of scene depth like this one, there are going to be ways to break it, because if it can't see the thing that it's colliding against, trying to put my camera in a position that'll break it, notice that the emitters here are doing a very different thing when I look down versus when I look up. It's because here, I can't see what those particles are colliding with. And if I can't see what those particles are colliding with, they're just going to make their way straight through the sphere. So see that? When I can see the sphere, they hit the sphere. When I can't see the sphere, they pass their way straight through it. Okay? So this is, like I said, an important aspect that if you're seeing some weird things happening with some of these effects, there's a good chance that it's something like that you're seeing. So just be aware that if something exists in screen space, it may have some issues. Okay? Now over here, again, what we're seeing is if I was to open up the emitter itself, you can see that this has a couple of things attached to it, but one of them is this bone socket location, which is having mesh data read into it. And that's how they're spawning the fire across the surface of a person. Now, this is... The vector fields is another thing that I'm just going to open on Cascade. As I said, I'm just kind of stepping through these, so my apologies to anyone that already knows Cascade and you're like, why are we doing this? It's because I just want to make sure that if people open marketplace assets, they're not too scared. Over here we're using vector fields, so if I turn off these vector fields, we can see that these particles themselves are just spawning and not doing anything. However, you can actually bake out 3D volumes that are essentially volumes made up of little arrows that point in different directions. And when you do that, you can make these particles follow the direction of those arrows. So you can see here that we're getting this kind of cool, magic-y looking effect. You can then also get those fields and rotate them. And when you rotate them, you can end up with some really, really pretty effects that are kind of just pre-baked out in a way. And you're using that information to make some really impressive stuff. So vector fields are pretty common. They're pretty common in your elemental looking things. They're pretty common in anyone that's doing really magic-y kind of effects. But some folks do use them as well for things like fire, or if they want a very specific particle bake to get things moving in a certain way. One node that may catch people off guard is this node here that's called Sphere. Sphere is literally to start the particles in a given radius. If I was to drop this to 0, they're all spawning at the exact same point. Whereas if I crank it up to 500, they're spawning inside of a 5-meter radius. 100, we'll put them all back here. Okay? So, with those kind of pulled down, the next thing that I'm going to do is I'm going to close this and I'm going to move across. And the other one that's very easy to catch folks off guard, body node. This can be really useful, but again, it'll catch some people off guard. So a black body node is a really cool little feature whereby you can actually base a color value on black body radiation. So I can see that when I open this emitter, it has all of its usual stuff. However, if I look at these values, I can see that one of them is called dynamic. And this dynamic value, when we graph it, is, fit vertically, is going all the way up to 4500 at its beginning, and then all the way down to a value of 0.65, it looks like. And the reason for this is setting a value called black body radiation. If I open up the material that it's using, I can see it has a node inside of it called temperature. Well, dynamic parameter, in which they've rebound the red channel to something called temperature. But most importantly, it's running into a value called blackbody. Now, what a blackbody node does is when you read something into it, it actually converts from Kelvin to the color value that we should be seeing. So it actually drives it off of a realistic curve. Now, the cool part of that is, if we wanted to see what 4500 Kelvin looked like, I can just plug this straight into a blackbody node. I can see that it's all the way up here. Whereas if I wanted to drop this down to something a bit cooler, we're going to get this very dark red. Okay? So like I said, having this kind of being driven through the particle, on the other hand, means that instead of setting the color of the particle, you can kind of set the temperature and let it drive that information inside the material from there. Cool. So with that kind of put together, I'd say that was it for the core things that I really need to look at for these effects. Oh, actually, it's worth looking at beam emitters as well. My apologies, folks. Again, If you see anything like this going on inside of an emitter, it's because you can right click and go emitter, and you can set up type data and add beam data. And when you add beam data, that beam data is then going to let you add a source, a target, and noise. If I turn the noise off, you'll see that we have just a very flat beam. Whereas if I turn this on, you can see this thing jittering around. And this is just spawning beams over time here. If I seem antsy, it's because I really want to get into the good stuff. Someone said, is there anything in Cascade that Niagara can't do or does worse? I believe on a performance level, I could be wrong, but I believe there are some smaller level particle effects in Cascade that are still more efficient than in Niagara. It's a pretty negligible hit, but some very low level particle counts. Whereas when you start getting into the high level particle counts, Niagara is going to just be singing. Okay, so I'm now going to go into the Niagara room to start working on my own stuff. And actually no, I'm going to open up a new project and we're going to work out of that one. Yeah, that's a good idea. Alright, so I'm just going to open up a new project. Give me one second, folks. It's time for us to start looking at Niagara, because like I said, I just wanted to step through some of what was here, but I didn't really want to make it the focus. Give it just a second. We're opening up another project which we're going to be using for the rest of this presentation. Okay, we are up and running, streaming. Cool. So this is the environment we're going to be using for the rest of this presentation. It's just kind of a reasonably straightforward interior environment, nothing too fancy. This was built off of a demo sample that we had. I just kind of added a city outside so that I had something simple to work with. I'm going to hide a few things like those cameras, but we should be good otherwise. So we've got this running, and it's time for us to start kind of working through what we have. The first thing I would like to do is make the world's most boring Niagara emitter. Okay, now I'm going to right click, I'm going to create a new folder, and I'm going to call this we've already got an effects folder, which I don't want to double up on, so I'm going to call this Workshop Effects. I'm going to right click, go to FX. Now, this is where a lot of people get thrown off guard, okay? And this is a very easy place to get scared. But what we're seeing here is like Niagara dynamic input scripts, Niagara effect types, Niagara emitters and function scripts and module scripts and parameter collections and Niagara systems, and working out where to start is a bit daunting, you know, like you see all of these things at the same time and you're gonna be like, ugh. So let's only focus on one thing. If you're trying to get used to visual effects inside of Unreal, and you want to get your head around particles, start with systems, and you're gonna have a much better time. So when you start with the system, we can actually go ahead and we can base it on a few things. One of them is we can say new system from selected emitters. And this is kind of cool because it means you can actually create a new emitter, but you can select some of these things and say, hey, I would love it if this emitter was based on a fountain, and it will just give you a fountain out of the box, you know. Or you could say, hey, I wish this was based on hanging particulates or a static beam, etc., etc. So this is actually a really good thing, because what you can say is like, okay, well look, I'm about to make an effect, and it's going to need to have some sort of explosion, and it's also going to need to have some sort of hanging particulates, and it's all going to happen around some sort of directional burst. You know, so you could really easily say, hey, I want these three things, and if I was to click OK, it would give me them. I'm actually going to strip this back to something reasonably simple. I'm going to go with just fountain to begin with, and hit OK. And I'm going to call this FX underscore simple system, because I'm not very inventive. Okay, so this is what we can see here. So this is Niagara. Okay. Now Niagara, as I said, is the newest system. It's much more powerful. You can do a lot more with it, and I hope you kind of understand why as we work our way through. Now, it works in a similar way to before. You know, you have a stack of different things that can be done. The difference is that while the previous system passed around information like color, the idea of color in Cascade is like hard set. Whereas in Niagara, everything is just a variable. You can create more variables. You can pass info around. Anything you see here is actually its own little node graph as well. So if I wanted to look at this concept of gravity, for instance, if I double clicked on that, I can see that the entire concept of gravity, this is its own little node graph that is getting the current physics force and applying some gravity to it, and then just setting the new value of physics force as it moves along. You know, any of these things can be opened up and worked with and modified. Now, this is a double-edged sword. This means you can really, really, really just like break the mold and do incredible stuff. However, you can also break your own effects in some pretty crazy ways if you're just learning. So, you know, you've got to, my advice for learning Niagara when you first get into it is wherever you can, don't double click on any of these things until you've really got a feel for what's going on. And then let's slowly dip our toe into the water to understand what some of these are doing and how to kind of build some effects. Okay? So again, you know, with what we have here, I can see that we have a fountain because what it's doing is it's applying a spawn rate over time and it's just sending effects into the air. So if I was to say, hey, I want to get some more of these or some more of these, we can get something going on that's a little bit prettier. So the next thing that I'm going to do is I'm going to make a slightly more interesting effect. At the moment, by default, this has gravity, force, and drag kicking in. And I think I'm actually just going to turn them off for the minute while we kind of work with what we have. And we can now see that that initial thing here is adding velocity. So let's do a breakdown of what we're really seeing here, because this is a bit different to Cascade. Cascade had everything in a stack, whereas when it comes to analyzing something in Niagara, how it works is this. Whenever the emitter updates, it's going to run these functions. Whenever any particle is created, it will run these functions. Whereas whenever a particle is updated, it will run these. So it actually has like a breakdown where these things are in separate places that are just getting the existing layer of information and changing it as we see fit. But in this situation, what we have is, again, like this is running during the update and this is running during the spawn. So I can see that the add velocity in cone is great for a particle spawn effect, but it may not necessarily be great in an update effect, because what's going to happen is, see how these are running much faster? It's because every tick we're adding that velocity again instead of adding force. And that's also really important, is understanding the difference between adding force to something and adding velocity to something. If you were to add 100 kilometers an hour to something moving at 100 kilometers an hour every millisecond, it's going to just leap up and you're going to be 1 millisecond in at 200 kilometers an hour. And that's not a good time for anyone. Okay, so we've got this in, we're all set up. It's time for us to kind of make this do something cool. So I'm just going to wing what our something cool looks like, and I'm going to begin by adding a sphere location. Oh, there already is a sphere location in play. Sorry. I'm going to get the sphere location, and I'm going to increase its radius to spawn them in a ball. Okay? We can see here now that we have 150 units across, so we've got this ball of particles. Let's make them do something interesting. In my particle update, I'm going to add some curl noise force, which means that over time it's going to keep adding force again and again. Now, every now and then you'll get this pop up where it's going to be saying, hey, something is terrible, things are broken, what's going on? And the reason for that is this. Remember before I said that gravity was just adding force over time? Well, the interesting thing is this, is that if I was to open curl noise force, it's doing the same thing. But if you think about the idea of adding force, if you're adding force, you still need something to apply that force and add that force to your current velocity to calculate your new velocity. And that's what this node here does. This node has to be after every single force that's being applied. And it's going to complain about that. Because what we're actually seeing here is we can see here that the effect itself is saying, when this is after it, it's going to say, hey, I need this to be repositioned. And a cool little thing you can do is literally just say fix it, And it will, because it knows this is a problem in a reasonably straightforward way, it will do its best to kind of resolve the issue and correctly order the things again. But it does have, I put this down here again, dismiss issue. So dismiss issue is like if you're intentionally doing something really weird, it will still throw a warning, but you can say dismiss, and it's like, all right, I won't complain, but I will judge. And then you can work on from there. Okay. So we've added some curl noise force, and we can see it kind of taking place. See how we have a couple of particles, they're moving a little bit. So let's up the strength. We can now see that these are kind of starting to work their way around. Now let's work through this in a, let's go ahead and make this a little bit more interesting. At the moment we have scale color, okay? So scale color goes ahead and it's scaling the color that has been set initially by these values. But what's kind of cool about this is scale color is scaling the alpha over time, which is making the particles fade out. But if I was to look at the scale RGB, if I scale the red channel up, we get this, okay? Or if I was to scale, crank it up a lot, we can get some crazy effects going on, right? But what's really interesting about this is this concept of scaling the RGB, it's up to us how we scale it. Because see how the alpha has a scale over time? So this is like over time, we're starting here and then going down to this. We could do the same thing with a scale RGB. So anytime you have an input like this, where I have 1, 1, and 1, I could click here and say, let's say I wanted to make this a curve. So I want to make a vector from a curve. At which point I could say, at the start of your life, I would like the blue channel to be here. I want to grab the green and red and put them up here. And we can now see that we're scaling that differently. However, if you ever want to do scale color in a very clean way, I would suggest using this called RGBA together. And hopefully this one makes a little more sense. Because you can see here that we're grabbing this. And if I say, treat this like a color, so this is looking for a vector, and I can say, hey, give me a color, I can now use this to just use a color picker to select it. And all right, that's kind of cool. But again, because this is all just like stacks of dynamic inputs, I could get that color and I could turn the color into a curve over time. And I could say at the beginning of your life, I want you to be red. Then I want you throughout your life to turn blue. And then when you die, I want you to be white. And over here, I could set this scale value to keep them so that they're not fading out either. Because the bottom values control the alpha, whereas the top values control the color. So see how we're just able to kind of just pass things around and deal with them in different ways? Like I personally think that's really cool. But here's where it gets even cooler. So see how these particles right now are following the concept of their age. That age is because it's looking up a value called normalized age, where an age of 0 is here and an age of 1 is here. But here's a really cool thing. What if instead of looking up the age, we wanted to start looking at something else that was weird? Like let's say we wanted to look at a distance range. If I looked at a distance range, I can now look at a start position and an end position and a distance, okay? And what that means is that if my start position is going to be, let's say we want to base it on the emitter's position. Position. I can actually just look up the position of my emitter. I can then look up my particle's position. And now this distance value, okay, this distance value means if I was to type in 500, if the distance from this to this is a value of 500, it's now a value of 1. Whereas if the distance from this to this is like a value of 0, it's going to be 0. If the distance from this to this is a value of 250, it's going to give me a value of 0.5. So it's literally just dividing the distance by this number. But do you see what we have now? By doing it this way, any particles that are in the middle are now red. And as they move away, they're going from blue to losing their alpha, to transparent. So we're actually controlling this entire system based on distance values, because you can just kind of pass information in any way you want. And this is where Cascade just could not do it. You couldn't even begin to touch this kind of stuff in Cascade. You would just have a bad time. So we've got this going on, and we can see some really cool stuff, because what if we wanted to do some really interesting effects, right? Like, what if we wanted to get something like this, and we wanted to say to it, let's put this in the world. Gonna get you. I'm gonna drop it here, and I'm just gonna put it here. So as I said, we can now see that these particles start their life one color, and then they slowly change their life to another color, because it's not based on their age. They're changing their life based on their... Someone said, has your alpha become disconnected? So the reason they're not fading is, you're exactly right, to whoever asked that. It was Luke. You are exactly right, because it's not connected, because its alpha is still based on here, okay? And that is 100% correct. And that's why, if we wanted to, we could also, if we wanted, base the color, base the alpha on life as well as distance. So for anyone that's not following what we're yapping about, it's that these particles are not fading out of existence. Do you see that? They're actually just popping out of existence. The reason they're popping out of existence is because they never reach 5 meters away, which is when they would become invisible. Okay? So again, if I wanted to, I could actually scale the color again. So just add another node. And what I can do is I could add this other node, and I could say, I want to scale these separately, but this time I just want to scale the alpha by age. And now what we get is the particles will both fade out when they get too old, or they will fade out if they hit the 5 meter mark. So it's literally going to multiply both of those together and give me both of those things at the same time, because I've just created a nice little stack. So we can now see that when we go back here, we have a much cooler looking effect where those particles don't pop out, like just pop out of existence like it's amateur hour. Okay, so we've got this cool little thing going, but let's make this a little bit more interesting. So the little thing that I haven't touched on yet is down here, which is render. Now at the moment we're rendering sprites. Okay, and every time we render a sprite, it's just giving me another one of these things, and I can change this material to any other material, so I can make all sorts of cool looking sprites. But what if I change this, right? What if I got this and I changed this to have a light renderer? So I'm going to get this, and I'm going to bring this down, so it's a little bit easier to see when I do what I'm about to do. But if I add a light renderer, I can now get this, and I could say, hey, I want the radius to be, let's turn this up. I want to have motion blur enabled, and I'm going to turn off inverse square. Whoa, I went too hard. We can now see that as these particles touch the surface, they're actually lighting up the environment when they come across it. Just going to move it a little bit further down. So we can see that these values are kind of being fed in. Now it's a pretty ridiculously high value that I have going on right now. So I'm actually just going to get my post-process, and for the time being, I'm just going to turn that bloom way down. So what it's actually doing is every single one of these particles is now spawning a light along it. And I can control how big that light is. And I can also control what the color is, or any of these other values, like the light exponent. So I could hard code in some of these values as I saw fit. So if I wanted these to be bigger, I could radius scale by 5. And now we have gigantic lights. Which is terrible, don't do this. So I'm going to keep this, even if I went 0.5, it might be okay, actually. There you go. So now we kind of get this nice little soft touch as they come close. But overall, what I would suggest you do is consider using, so I'm not using the an inverse squared fall off at the moment, which will give you a more realistic light, but they'll be very faint right up until the point that you see them. So if I wanted to do something like that, I would need to crank up my color binding. But the cool thing is you know, I can do that too, because what I could do is I could create a new parameter. And the new parameter is going to be a color binding. Sorry, give me 1 second. I'm just checking what this is. Oops, sorry, wrong thing. Parameters. Oh, it's right here, and I didn't even see it. Color by default is a linear color. Yeah, linear color. Cool. So what I'm actually going to do here is I'm going to create a new parameter that is going to be a color. And this is going to be called particles.lightColor. Okay, let's just go with that for the minute. So here's the cool thing. If I have particles.lightColor, which is what I've just created, in my light renderer, if I want to, I could say, hey, your color binding is now light color. Actually, I might set that on spawn. And I'm going to turn off the inverse fall off so we can see it. But notice now that the light is white, because the light is just pulling that information from another thing, right? Like there's nothing, it doesn't care if the value is called color. It doesn't, like I could feed in, if I wanted to do something real weird, I could feed in, instead of the light color, I could feed in the velocity as a color and, you know, feed it back that way. So having this kind of stuff is really useful. Because you can just do things that people never accounted for, and you can do it without anyone judging you for it, which is great. So I've got this, and I've put this in, but let's get this light color. Let's say that this color is going to be a float. I want to get make a linear color from a vector and a float. Actually, I want to change the different thing. Instead of changing the light color this time, let's go ahead and change, they have a value called, here we go, which is the light exponent. So I'm just going to set the light exponent myself. So I'm going to create, sorry, I'm used to typing the word create. Here, I'm going to create a new one, which is called, it's going to be called light exponent. So I need to create a new float. And I'm going to call it, I think it was light exponent. We can now see that the, I'm going to turn you on. Sorry folks, I'm just quickly setting things up. Go back to where we were. You can now see that because of the light exponent setting, see how this has a much softer value? So what I'm, sorry, this is a bit of a weird one to do because you're not really, this is much easier with multiple monitors, but I'll do my best to kind of keep things visible. But what I'm actually able to do here is, let's pull you across, is I can change some of these things as I see fit. So I could get the light exponent, and if I push it to 2 or 50, notice they have a much smaller kind of fall off. But the other thing that's really useful for setting up these colors is just going to here and setting up that final color add value that we're using here, which will just make them much bigger, much brighter. But what I want to do is, you know, okay, we've made them much brighter. I might want to go through and also change that radius value that we had. So I'm going to set that to 1. And see how that looks much nicer than the original version that I had? So getting the quick result by just turning off that checkbox is one thing, but when you turn it off this way, you can kind of control how nice the fall off is from everything. For some reason that's still coming through as white, which doesn't make sense. sense to me. Oh yeah, it's because the values. That's fine. Okay, cool. So we've got something set up there, but it's time that I start working on something cooler. I'm going to get rid of my light renderer for just a bit. Okay. I've gotten rid of my light renderer, and before I was discussing CPU and GPU particles. What I would like to do is make this have way more particles. Actually, just before I do, sorry, I realized I forgot something. If you want to use this, notice I can slowly scrub the system forward and see what all of these particles are doing. Cool thing is if I check this box called determinism, I can now play the entire particle system backwards and see where they all came from. So I'm actually going to decrease the sphere location size to be a little bit smaller, and we can now see that all of those particles are spawning there and they're making their way out. Let's make this even cooler again by giving them a longer lifetime. So we're going down. So I'm going to let them live for up to 5 seconds maybe. So we can now play it from there and see as it goes out that some of these are going to be living longer. So see how we got that going on? I think it's pretty cool. But anyway, what I wanted to show you before was this. If I go to GPU sim, first thing it's going to do is complain about fixed bounds. I'll get into that in just a bit because we can still see the system without them, but it'll keep giving me an error and a warning until I fix it. But here's what you can do with GPU that's great. If I want to spawn, let's make these really small, just so we get these nice, tightly packed particles. Okay, I'm going to get these, and I want to set the sprite size. Let's go with like a value of 2. Cool. So we can now see we have these just millions and millions of tiny particles. Like at any given time, this is, oh, that wasn't millions and millions. Sorry. Let me crank this value up so that I'm no longer lying to you. That's only 150,000 particles. If we wanted to, I can go to my spawn rate and let's just add a 0. And you know, if I wanted to, we could go back and look at some of these curl noise structures that we have to make some pretty interesting stuff. So what I'm going to do is we have the noise strength. I'm actually going to add sorry. Probably want to get something that's going to have a bit more of a vortex going on. There we go. So I've added a vortex force this time, which gradually gives them this spinning value that's going in. If I want to turn off any of these things as well, I can just uncheck the box at any point. Cool. So we're now kind of like starting to get some kind of cool stuff going on. But like, let's have some fun and let's just do something really weird. Okay, I got one. So we've got these particles, and as they, they're spinning out and they're doing something cool, right? But what about if we got this particle system and we said to it, I want you to be attracted. I'm going to add a point attraction force. Now let's give them a point to be attracted to, and a strength. I'm going to make this 200. Now you can see that at the moment they're all being attracted inwards because by default the attracted position is the simulation's position. So they're all being attracted back to the center. The interesting thing there that's just noteworthy is we actually are basically creating the general rules of a like how a solar system works, because we have an attraction value, and if they reach an escape velocity, they're kind of just pulling away from that, right? So if I was to crank this up to 250, you know, it's harder for them to get away, but eventually if they do, we kind of get that going. So that's cool. But anyway, so we've got this going on. I'm going to set the radius to be, say, 500, and I'm going to set the attractor strength. Let's put something. Let's do 20, for instance. But here could be a fun one. Maybe instead of doing the attractor position as the simulations position, maybe we could go ahead and do something kind of weird. Like we could get that position and we could add 2 positions together. So I could get the simulations position and I could just add 200 to it on the z-axis. If I do this as a smaller value, see what's going on. Let's look at that in the world. So they're getting pulled up to some cool spot in space, like floating high above them now, right? Because what we're again able to do here is we're kind of we're just stacking these, you know, like, so we're stacking the forces. The first force is saying, hey, get me curling around something, and the next one is going, no, bring me up to here, you know? So okay, we're starting to get something kind of interesting. It's kind of cool, and we could tweak this as we see fit. It's worth noting as well that we can set up user parameters, which is cool. So I could say, I could create a user parameter that was a float, and I could call this, just attraction strength. I'm just gonna set it to 5. And I'm gonna have another one that I'm gonna set as a vector that I'm gonna call attraction offset. And I can actually just bind these to these values. Cool. So, you know, I bound it here, but here's the cool thing. This means I can go to here and I can get this effect, right? By the way, I gotta be honest with you, I'm just totally winging what we're making here. And I could say, hey, I want this to be attracted to, I want the attraction strength to be a value of 1. Whereas I could create another one, and I could say to this one, I now want you to have an attraction strength of 10. You know, and I could say that, hey, maybe I want the offset on this one to be, negative 500, so they're getting pulled downwards. Or maybe I want, maybe something that's basically in the center, so they're getting pulled back in. But you know, so the cool thing is by being able to have these as user variables, you can create the one effect and have a bunch of different things. And we could fool around with these as we see fit by just setting them up in different ways. So we can see that's kind of doing something cool. We're getting this thing where this is getting pulled up the beam. It's looking kind of interesting. Let's go ahead and I'm going to... I'm going to fix one thing first. So before I mentioned bounds, and then I just skipped off the topic entirely. Now, here's a problem with what we've just built. Look at the effect. Ready? See that? Hopefully you do. What's happening here is this effect... when you're running things on the GPU particles, they actually don't know how big they are. So if this was CPU, it would be fine. But on a GPU, it doesn't know how big the system is going to get. So what you actually need to do is you need to set fixed bounds and have the fixed bounds basically say this is the size of the cube, that as long as you can see this cube, assume that we need to still be calculating stuff inside of the system. So I'm just going to set this one to be 500, 500, 500. And now we have a 5 meter cube. That's 10 meter cube, really. So this is now no longer going to cull. See that? Cool. So the other thing that I didn't mention before that I think is definitely noteworthy is, again, all of this information is purely data, which means this thing here that is the attraction strength. Let's ditch this notion of attraction strength to begin with, and let's actually use a curve. Because again, you know, I could just feed this in. I could say, hey, at the beginning of your life, don't be attracted. Over the course of your life, I want you to be attracted. And let's make that a curve. So we've got some nice values going on. And we can then scale it as we see fit. So I can scale this by 20. And now only old particles are going to be going towards the heavens. Any new particles won't do it. You know, and if I wanted to, I could kind of drop this down and I could say, hey, I want you to be a value of 0. Oh, sorry, I want to do a break. And I want you to be linear. Yeah, there we go. So now they're going to stay there, and it's only towards the very end of their life do they start to lift up. See, now we're kind of getting that aspect where it's only those outer ones are starting to kind of pull up here. And it's because we can just pass information around, we can do whatever we wanted, because like nothing would stop me from creating this as a parameter and then feeding that value into everything, right? So at the moment I'm just dropping an arbitrary curve in here. But let's say we wanted to create a new, I want to create a new parameter, and I wanted to call this, this is going to be a float. I'm going to set it up top. And this is going to be called like attraction level. And I could set the attraction level to be a float from a curve and just do the exact same thing that I just had there, right? Just setting everything up. The value of 0. Curve you out, bring you down. Cool, that'll do it. Yeah, that'll do. Cool, so we've got something like that going on, and alright, that's kind of cool, but here's the thing is, if I was to get something like this, and I was to grab my attraction level, I could go back to my point attraction force, and instead of binding it to a curve, I'm now able to just say your attraction strength is attraction level. But the cool thing is I could also do weird stuff, like I could scale the color by attraction level as well. You know, like this normalized age is purely your attraction level. So, you know, if I wanted to, I could just throw that in there, even though that doesn't make a whole lot of sense. So all I'm kind of getting at here is like we can just pass information around as we see it fit. We can do some really cool stuff, and it's really the advantage of Niagara is you can treat some of these things as new and weird and wonderful things, right? So, all right, that's kind of cool. I'm actually, despite showing you how to do all of those curves and things like that, I am just going to bind this to the user value that we had before, which was attraction strength. So let's do something different. I'm going to turn the fountain off for a little bit. I'm also going to rename it to be like solar system thing. I guess solar system, that'll do. This time I'm going to create a new emitter. And again, if I was to right click here, you'll see that nothing's popping up. But if I go to show engine content, it'll actually have a bunch of extra things. So make sure you have this show engine content enabled, okay? Otherwise it will only give your existing emitters that you have. So this time around, I want to create a, I'm going to create a, let's go a dynamic beam. Cool. So this time we're working with a beam instead of working with a a particle just by itself. Okay. Now here's what's happening. The emitter state kicks in. We then have a new node that we haven't seen before called beam emitter set up, which is like, hey, where do I end? And I'm going to tell it you end at the offset value. And all of a sudden we have a beam that is going upwards. At the moment it's spawning as an instantaneous burst. And it's spawning this many across the length of the beam. Now, the fun thing here is like all of these values that are inside of the beam are actually being handled again by just arbitrary things like a curve, except instead of the curve being the age, it's the ribbon link order, whereby the things closest to one end are this and the things towards the other are this. So let's take a look what that looks like. First off, I'm going to push this out to a ridiculous amount so you can see it. But these are literally just curve values being read in. Okay, so we have some kind of strange stuff going on there, but that is the beam width, right? So okay, I'm kind of fooling around with this, doing some strange stuff. That's fine. Let's for the time being get a beam that has a. Let's actually set a reasonably steady beam. It only really gets towards the ends that it branches out. But what I would love to do is when we initialize it, let's go for a really bright color. What's the center color for the thing we had before? It was kind of a reddy in the middle, I think. Let's just look it up. Yeah, it's kind of like a red. Cool. So let's go ahead and set the initial color to be something like that. So 200. Oh, hang on. My apologies, folks. So it looks, this is an easy gotcha, and I think it's something we're fixing moving forward. So my apologies for this being the case right now. But the default ribbon material actually has some extra logic built into it, which automatically fades. As such, I strongly recommend you don't use the default ribbon material. And instead, I'm just going to create a new ribbon material now, just for us to use instead. The good news is ribbon materials are super easy to make. Because you plug that in, and we plug this in. Actually, we probably just want this to be additive. What did they use? Additive and unlit. So I'm just going to set it as the same. Blend mode, additive, blend mode, unlit. This is literally all you need to get this basic ribbon material going. Now, the static beam is also overriding the color value, so I'm just going to delete that one from there so I can use this. There we go. Now we have our beam going. Cool. Now, let's say the next thing that we wanted was this, and this is it in the world, by the way. Let's say the next thing that we wanted was for this beam to so we wanted to change the position of some of these particles over the course of their life. So at the moment, I'm spawning this single color, and I'm just going to go to update. And in much the same way as we saw before, I can literally just say, hey, let's add curl noise, for instance. Oops, sorry. And you can see that when we do this, every particle is still connecting to its previous one. We're kind of just ending up with some really weird offsets, but that's okay. So we've got something like this going on, and all right, that's kind of cool, but what else could we do? Well, why don't we add a, why don't we get the position, and let's you may fire when ready. Exactly. Let's go ahead and get the. What could be a fun way to do this? All right, let's make a. You know what? You want to make a Death Star beam? Let's make a Death Star style beam. I think that has like a circular beam around the outside and then a straight one through the middle, if I remember my Death Stars right. So let's go ahead and look at something like that. I'm going to get the. I want to access the current position. So I want to set new or existing, and I'm going to change particles.position. I'm going to look. Sorry, folks. I've taken the challenge, so I'm just doing this. I'm going to get the. Yeah, great. This will work. All right, so I'm going to get the position. So we can access the particles position as particles.position. I'm actually going to change this into a value called projected position, which is now just currently the projected position is going to be equal to the current particles position, and I then want to set this to great. So there is a beam. Cool. So we can use the normal and the binormal and the tangent. Yeah, that'll work. Cool. So what we could actually do if we wanted to do something kind of crazy on this is we could look at the direction of the tangent, and if I was to get sorry, I'm just adding. That's going to be adding a vector. That's going to be adding a vector. No, I only want two. So it's times like this where I should have actually done it as a scratch pad, but I'll show you that in just a moment. So this one is going to be equal to the normal the tangent. Yeah, there we go. The beam spline tangent with the cosine of time. That'll work. And scale that by like 20. So at the end, I could then comfortably go to the ribbon that we're rendering and tell it that the positions that we're rendering are based off of projected position findings. Here it is. Oh, have I made a mistake? I may have. I'm sorry, folks. Alright, looks like we're not going to go down that death laser. I would have thought the normal and adding it to it would have done it. Anyway, that's okay. So we've got ourselves this beam. We're kind of doing a general position at the moment. Everything is fine. I'm going to go ahead and I'm now going to set up another thing whereby if we wanted to, we could set up this the setup that we have. Instead of this being infinite, what if I just spawn this beam one time? Now they still have a lifetime, so I'm going to get rid of their lifetime. Shouldn't have cleared it out unless lifetime doesn't default to 0. Sorry, just quickly checking out what I've done wrong. This is correct. This is correct. The loop duration is infinite. Great. And great. So I'm just going to set U to loop. Current loop duration. Great. So we now have an infinitely living particle. And if I turn both emitters on at the same time, we now have this. The cool thing is these, actually I'm going to make this more of a pinky color to kind of match what we have down there. The cool thing with what we have going on is this is kind of doing its thing, right? But this attraction offset is completely controllable. Like if I wanted to move the beam to be diagonal, those particles should be attracted to the end of the beam. Oh, I know why they're not. Sorry. The reason they're not being attracted to the end of the beam is because I have an attraction radius, which I can just crank up. And again, you know, I can kind of dynamically just mix this around to wherever I need it to be. Kind of create some really weird effects, but that's okay. You can also do some insanely high attractions to get some other really weird effects. So these are actually fading out because of the particle rules that we set up before about particles fading out over life. So if I wanted to change something like that, I could go back to this and just set this value to 1. Now we end up with that. Cool. So hopefully this is generally kind of giving you an idea of how these basic systems work. Like it's nothing too fancy, but you know we can kind of create some cool stuff out of it without doing too much. So the next thing that I want to touch is let's make something that you haven't seen before. How am I going for time at the moment?
You're about an hour 15 in.
Hour 15. Yeah, okay, cool. All right, so let's have some fun. Let's go ahead and have a bit of fun. What I'm gonna do is if I look out here, see this car? If I hit play, oops, I have music on. That's okay. We have this guy just kind of like floating around, right? Now this is a really simple little blueprint that I threw together. It's nothing too fancy. But what this is actually doing is it has a thing on it called a render target. And let's take a look at that. So a render target is this. And I want you to watch what happens as the thing flies around the world. Everyone see what that's doing? As it flies through the world, it's actually filming what's going on beneath it. And because it's filming what's going on beneath it, this is something we can use for some pretty cool effects. Okay, because as it films what's going on beneath it, we could pass this information into Niagara. So let's take a look at what something like that would look like. Full disclosure, the effect that I'm making right now is one that I have not made in quite a while. And due to a slight mishap, was not able to properly test it before this began. Okay. So I'm going to go to, once again, create a Niagara system. I'm going to base it on, honestly, just an empty blank emitter. Add. Finished. I'm going to call this fx_hologram. Okay. we have our emitter. Nothing's going on right now. So to start with, I'm going to give... I could spawn the particles directly into a grid, but I kind of don't want the effect to look like that in the long run. I want to just give them a spawn rate and spawn... let's spawn 1,500 of them for the time being. Okay? Right. Now, if you think about the image that we had a second ago, the render target, I think it was called camera. If you think about this texture, this corner represents 0, 0, and this corner represents 1, 1. Okay? Which means that if I wanted to recreate this out of particles, what I would need to do is I would need to give every single particle a random value between 0 and 1. Okay? For both x and for y. So to do that, it's really simple. Whenever the particle spawns, I'm going to create a new parameter that is going to be a two-dimensional vector. So what that means is I'm creating a new parameter that is holding the x and y value. And I'm going to call this particle UV. Okay? And I'm going to set this to be a random value between 0 and 1. So, cool. I've hit OK and I've hit save. It's now between 0 and 1. And if I ever want to check this, one thing that I haven't shown you yet is there is a thing called the attribute spreadsheet. And if you click this and hit capture, it will actually give you every single particle that currently exists and every single value it has across the board. And this is really useful for debugging why something just happened. You know, when you're like, what? This is really, really, really useful. So keeping this in mind is like just for debugging purposes, you know, I swear by it. So we've got this as a random value between 0 and 1. Sorry, I failed to actually demonstrate that the thing that I just did worked. But if we scroll across, we can see that particle uv.x and particle uv.y both have values in them. So this is clearly working. Okay. So the next thing to do is let's just double check that this is really working. And what I'm going to do is I'm going to set the particle's position. I want to set existing value to be the position. I want to set their position to be equal to the actually it's almost easier to type this in manually. So here's a cool thing that you can do. If any of you are used to HLSL, you can just type raw HLSL straight into this. So if you wanted to, I could say I want to get a float 3 of this multiplied by particles.uv and at this point that I ask, I called it sorry, particles. Did I call it particles UV or something? What did I call the parameter? I've already forgotten. Particle UV. Particles.particle UV. Cool. And I'm just going to multiply. Let's go bigger than 400 just so we can really see it. So you can literally type HLSL straight into here. And it should work. Oh, it's because I'm multiplying these all by 0. Sorry. And I'm going to set this to be 400. Great. Now, this is literally just, like I just typed this in manually as a quick thing, so it's up to you. If you're comfortable with HLSL and you know this already, then you may want to use this. all I'm doing right now is I'm literally multiplying those X and Y values by 400. What I'm doing here is not necessary for the rest of this effect. It's purely for the sake of demonstrating things, okay? So don't get freaked out about me loading that up. I totally understand why you might, and I myself would have, like, a while ago, when I was in the same position as a beginner, so don't panic. Anyway, so we've set this up, and what I'm actually going to do is I'm going to say, I want you to sample a texture. Now, it's going to say, all right, so we need a few things. First off, it says that sample textures don't work on CPU emitters. So I need to switch this over to GPU. Now, if I go back to here, the other thing I need to do is tell it a texture. So I'm going to tell it, hey, use the camera's texture. But that's not all. I also need to give them a UV. And I can do that with the variable that we created, called particle UV. And I'm going to increase the density so we can see these. Now, this still doesn't appear to be working. And the reason it doesn't appear to be working is this. I'm sampling the texture, but I actually still need to set the color. Right now, what I'm actually doing is accessing information from this texture, but I'm not setting it to be my color. So I need to literally just add a color. And this color is going to be the sampled color. And here's the cool thing. If you look at that grid that I just loaded up, see this? I'm going to run this. And notice that as the camera moves around outside, we're actually seeing... Sorry, I'm going to flick this back to real time. I can't run real time at the same time. That's fine. I'm just going to do this a bit. So what we're actually seeing is it actually is literally drawing the trees and everything that the camera outside sees. Okay? So this is the start of what we're doing. And Luke Harris is clearly one step ahead of me, and that is that, yes, we're about to use the height data. So a really cool thing that we can do is, before I didn't tell the entire truth. This camera is accessing the color data, but importantly, what it's actually also loading into it is height data. So the alpha channel of this is actually storing the distance to every single particle that it sees. Now, here's the cool thing. If you know the distance and you know the field of view of a camera, you can actually reproject particles into space. So I'm going to turn off this so they're no longer in a grid, and I'm going to use a new thing called recreate camera projection. Now, when we do this, it needs to know a few things. First off, it needs to know the depth value. And that's actually pretty easy, because I need to just look at the alpha from the sampled color. Next up, it needs to know the field of view. And I can't remember this off the top of my head, so let's go out and take a quick look. Here's my camera. It's got a field of view of 45. That makes sense that I set it to the default. So, field of view is 45. Now next up, it needs to know, all right, that's cool, but what is your projection space? And I'm going to say, well, the UV location is particle UV. Now it needs to know which way it's projecting, and I'm going to say, hey, I want you to project downwards. And one last thing I'm going to do is, because this is a GPU emitter, I'm going to set some bounds to be incredibly high, just so we can see this thing. And I'm also just going to increase the size of these particles, just so they're super obvious as to where they are in the world. All right, so what have we got? Good question. Let's get the hologram. just bring this over to here. You see that? So we've got this, and the cool thing, you know, I'm going to crank that particle effects value up. Let's just add some zeros to this guy. Much better. I'm actually going to shrink down the size of the particles too, so that they're incy wincy. Cool. Now here's the cool thing. If I run the world and have the camera fly around, cool. So we've started to get somewhere and do something that's you know, pretty cool. One of the fun things as well right now is one of the main things that's right now that's causing overhead is like I'm spawning 1.3 million particles, but one of the main things that causes overhead is this interpolated spawning. Now, this used to have a bug. Hopefully this doesn't destroy everything. I'm going to save this project first just before I turn this off. Great. So now we have no frame loss and we have way more. And if I wanted to, you know, I mean, if I wanted to, should I see what happens? Let's see what happens. Cool. All right, so that's kind of cool. We can see what's going on here. We can see some fun aspects involved. And there's some pretty cool things. We can see that has anyone noticed it keeps disappearing? It's a bit of a strange effect, right? The reason for that is because technically the emitter is all the way up here. And in case you're wondering what the redness is, the redness is, I have a laser. Where's my camera? There it is. I have a debug laser that is being projected downwards as it flies around. So it's actually drawing that. I can turn that laser off super easily. The next thing that I'm gonna do is I'm gonna quickly just turn off that laser because it's gonna drive me nuts. Where is your laser? Debug. No debug. Great. So we're back to having our thing. Now, the first thing that we now need to, well, not the first, but one of the things we now need to actually really go ahead and address is that the emitter is all the way up here, and yet the system is all the way down here. Anyone want to take a guess? I know there's a 10-second delay here. Anyone want to take a guess as to why it's so far away from the emitter? So the reason that it's so far away is because that's how far away the camera is, and we're recreating what the camera sees. And what I would like to do is pull everything back to the size of the emitter. So I would love to pull this all the way up to here. And tragically, that has not been done yet, but that's okay. So I can do that myself. All I'm going to do is I need to create something that gets the position and moves them upwards. Now, that means I need to know how far off the ground my camera is, which I keep losing. There he is. And he's about, I want to call that 40 meters off the ground. So I'm going to call that a value of 4,000. Now, fortunately, we have old mate trigonometry. Now, if I want to get this hologram and move it this way, that's the first part. That's easy, because all that is literally I would set the position. So I was about to do it one way and then realized I don't actually want to do it that way. I would just set the position to be the projected position with an offset. Okay? So what I'm actually going to do here is I'm going to use a really, really, really important feature in Niagara. I can't stress enough that this is important. No tutorials talk about it because it only came out in the newest version. But if you click here and type in Scratchpad, it actually lets you create your own little nodes that only exist in the context of this emitter. So I'm going to create one called correct fix projection, fix camera projection. Side note, I feel like I'm accidentally insulting the developer that made the first one every time I make a node like that, because it sounds like I'm insulting them, and I'm like, ugh, I'm just fixing your thing. So this actually lets me get information and then do something with it. And the great thing there is, I can set this up pretty easily by just saying, okay, I want to set the particle position, and I want to have some sort of input coming in that's telling me I want to set a value called create a new parameter. I want this to be a new input that is a vector, and I'm going to call this old position, and I'm going to have another vector called offset. And in theory, old position plus offset should give me something. So we're literally just setting a value called position, and we're deriving it from these two. So if I always have to click apply. This is the easiest thing to miss. There's a little apply button here, which is in kind of a weird spot. Press that, you go. So we can see here that it's created a node for me. Like I've just made this, and the position, the old position, is going to be the camera projection position, and the offset is going to be, we know it's facing downwards, so it's an offset of 4,000. Cool. I'm going to hit save. And if I go back here, I can now see that it's in the middle of this, which is good. Actually, this actually needs to be a bigger value than 4,000. I think this needs to be like 5,000. Yeah, cool. So now I'm actually able to kind of comfortably move in and out of this thing and see what's going on. And if I run it, by the way, the music was actually accidental originally, but it sounds really cool, so I've left it. I hope you're okay with that. But now I'm actually able to move through this hologram and see what's going on, and that's kind of cool. But the next thing that I need to do is shrink this down and then make it the size that I actually want it. And this isn't as difficult as it sounds, because what I need to do is find out how big this thing is, and I need to divide it by how big it is, which gives me a value of 0 to 1. Like if every single one of these particles, if the furthest away it could get is 5,000 units and the middle point is 0, then if I divide it by 5,000 and multiply it by, say, 10, every value is going to be between 0 and 10. Now, it's not too important that you know this. I'm kind of just busting out some trig to do an advanced effect. But all I really need to do that advanced effect is to get... so tan is equal to opposite over adjacent. So I need to get the offset. I need to get the length. I need to get the length of that. And this is going to be... I'm going to need a new value, which is going to be the float, which is going to be the angle. And I need, it is tan of that, right? Tan is equal to opposite over adjacent. And then I multiply it by the adjacent. I think that's right. Yeah, sorry folks, I was just doing the math in my head just then. So I want to get, great, so I've got the old position, the new position, and I want to divide them by this times this, and that should shrink them down. The problem that I have with what I've done is this position is in needs to be in local space. So I'm just gonna, for anyone that's following along that understands what's going on, that's great. If this is not your general thing, don't stress. What I am doing is pretty sorry. I keep clicking on the wrong one. I keep clicking on. There we go. Okay. So I just need to tell this to go, hey, go from the simulation space to local space. Again, don't stress about what you're seeing right now. It's more of me showing that you can do this rather than teaching you this exact effect. That effect, that position divided by this multiplied by the float that I'm going to call new size. Again, like this is size. Cool, done. And then I need to put it back into whatever the simulations space was. Great. So like I said, this was less about showing you how to do this exact effect and more of the fact that you can create your own complex additional logic that is able to kind of affect things in weird and wonderful ways. Now, in theory, my theory is broken. Sorry, folks. I've clearly made a boo-boo somewhere. Sorry about this. I'll be just one moment. Now, tan of 45 is the angle in which the adjacent is this. Tan of 45 equals opposite over adjacent. We have the adjacent. So by multiplying them by the adjacent, that should give me tan 45 times A is equal to O, which is the opposite. I'm going to get the current position and divide it by that. And then when I multiply it again, oh yeah, of course. Sorry everybody, I forgot to do the really obvious thing of actually punching in the numbers. Good job. Yeah, it worked. My math was fine. Alright, we have way too many particles. But that's fine. So I'm going to move this down to here next. And let's actually put this into a cool position. Alright, so this is what's going to eventually be my effect. At the moment these are still pretty big, so I'm just going to shrink everything down and I'm going to reduce the number of particles. Sprite size, a value of 1. That's actually okay. So we've got this, it's kind of sitting there, and that's kind of cool. What I would like to do though, and this is the last little bit of my of this type of setup, is I would love these particles, instead of just spawning and representing the hologram, I would love them to spawn in a ring around and then recreate this as they move around. The cool thing is that's actually pretty easy, because I can copy the location of this first off, and then I can just paste the location into this. So that's put the hologram there. I'm going to move this up a bit. But the next thing that I really need to do is spawn them in a ring. And spawning them in a ring is surprisingly easy. Oh, just a thing as well. At the moment, this is writing to the intrinsic values. I'm going to turn this off. So what this means is this is actually setting the particle position, which is getting overwritten here anyway. So I just want to turn that off. And the other thing I want to do is, at the moment, I'm also creating a value called position. But if I was to call that adjusted position, it's now just saving its desired final position as it's saving its desired final position under a new value. And the reason I might want to do that is this. You'll notice I've completely broken the effect. Particles aren't anywhere. They're technically all in a single 1 centimeter dot in the middle. But I can now do whatever I want. So I could actually say, hey, I want to start all of my particles in a cylinder. And I want the cylinder to be a radius of, say, 400. And I could say, I want to... There is an outside... surface band only. And I'm now... Give it a sec. It's now spawning all these particles in just a simple cylinder, right? Now, how wide do you think that is? I'd say about 450 radius. And I want to offset them down, which there is. So I'm going to say, hey, move it down like, I don't know, I guess like 150. 450 was wrong. Let's go 470. Great. So these are all spawning kind of around there. I'm going to say, hey, I want the cylinder to only be like maybe 10 centimeters high. I'm going to set you to be even lower. That'll do. Now, here's the fun part of the setup that I just had, okay? The fun part is this. I can get these particles, and what I can actually do is, at the moment, I'm literally just storing the value as a position that's called adjusted position. But you know what I could do is I could actually set the particle's position to be a lerp, smooth lerp over time. And what this actually does is this says, hey, this is where I want to be. This is where I am. I want to slowly move towards that over the course of my life. And I want you to see how that looks. Nope, 50 was too fast. 1 is too slow. Goldilocks issues here, right? So these particles are now actually spawning on the edges and then flying into the center there. Now, like, we could do, again, like this, everything we're doing here could be controlled in whatever way we want. Like, we could actually control the convergence rate over life. You know, we could say, hey, at the beginning of your life, I want you to stay put. And then after this much of your life, I then want you to still stay put. But after this, I want you to move up to a value of 1. Keep you at a value of 1. And now, the particles spawn here, and only when they're old enough to move do they start to move. And the cool thing is they'll actually move up and down as well. Watch this. As the camera moves, they recreate themselves like sand, adjusting their position. See that? because they're always trying to move to their new position now instead of just being set to it. And you know, I mean, again, like if we wanted to have some fun with this effect, we could do that as well, right? Because we could scale the color over the course of their life too. So let's have some fun with that, and let's say, hey, I want to scale it so that I want to scale the. What would be a good way? Let's do this as a color. So I want to set this as RGBA. I want to bring this as a color. And I want to set the... So I am actually passing the color info from the camera. The problem is it's all gray. So if you look really closely, I've got too many particles. They're actually overlapping each other and becoming so bright that we cease to see the color properly. So I'm sad about that, but that's okay. I mean, if I reduce the number of particles, you'd have a much easier time seeing some of these aspects. But hang on, let me just finish the thing that I was doing. So if I want to scale this, I could scale this again as a curve, because why not? And I could say, hey, over the course of your life, I want you... let's get rid of you. Let's get rid of you. Let's put you in. Set you at a value of 1. Great. Let's start these particles like really green. And let's have them stay green. Ish. Until they're really ready to move. And then form a new color. How great is this? And then we run that. We're good. And like, yeah, honestly, this would probably look better if, you know, this would probably look better if I had fixed up some stuff. Like at the moment, it's 400, so maybe we want to go with a, maybe if we want to go with a bigger hologram. Actually, bigger looks way cooler. I should have done that from the get-go. So you know, maybe we want to go a bigger hologram, and maybe we want to go a smaller baby spawn rate. Look at that, and run it. And again, this is all coming from a dynamic camera that's flying outside the window. It's actually just filming this stuff. So right now there should be some trees. There's the tree. So yeah, like I said, this was kind of a weird session, but I hope this at least gave people an idea of just conceptually how some of these effects work. And I mean, I wasn't here to show you how to make specific effects, because if I came here trying to make a specific effects, like here's how to make an explosion, and here's how to make a lightning, or here's how to make a, I don't know, something, that would be good, but it wouldn't really be, I think it was more important for me that I spent like an hour and a half explaining the system and explaining how data gets passed around and explaining like the hows and whys, rather than the like just the steps to make it. So I hope everyone can forgive that aspect of this, because it's you know what, I could probably make this slightly cooler now that I think about it, by setting this to be a value of gray. So, sorry, I need to scratch this itch and see if it looks any good. Adds a little bit of the color back. Cool. Anyway, so I hope this was useful. As far as the resources to learn more Niagara, there are some more. It's honestly, it's all me from as far as the videos from Epic go. Oh no, that's not true. Aaron Langmead had a video recently. If you look at the Unreal Engine. YouTube channel. Alex, do you mind dropping in a link to my one's called Building Advanced Effects in Niagara, and that's got Crunch dissolving into particles. So we're literally dissolving a character into particles dynamically. The other one is Aaron Langmead's Unreal Fest Online talk, which is really useful. And honestly, the docs for Niagara are pretty good. This was again, like I can't stress enough that like Niagara was not a real boy, so to speak, until recently. You know, it was not until we put it into active production that we were able to like really kind of refine this and make it what it is today. And that's a good point. Can we shout out Real-Time VFX? So Real-Time VFX is a great website. There's some really, really good stuff there. It seems like a really good community. I'm not part of it. Someone asked, is Niagara implemented across all platforms? Yes. So Niagara is actually used inside of Fortnite. So anything that Fortnite can support, Niagara just by definition has to be able to do. So again, like Niagara was good, and then we put it in Fortnite, and then Niagara got crazy good because it was being used by an actual team in production who were developing and sweating over it and groaning at issues and whatever else, you know? Like, nothing battle hardens a tool like putting the people that make the tool next to the people using the tool. So, I hope this session was okay. It was a bit of an ad hoc one. I know I made a couple of slip-ups on some of my math there. It wasn't even my math, actually. My math was totally fine. I literally just forgot to punch in the numbers, but I still feel a little embarrassed. Let's switch over to the Q&A section of today's session. And I'll just switch over to that. Sorry, folks. If I can find Discord. There it is. And
Oh, first up, Clyde Bicey asks, is that soon one of the free content packs?
Kinda. I can't seem to full screen out chat, and I feel silly. Sorry, buddy. There we go. Turned it off and on again, and that worked. Who knew? And for some reason, I can't see Tony.
Ah, yes, he's gone out.
He had to drop out? Alright, that's fair enough. Alright, so just dropping it back to us, and I'm turning on my camera. Go team. Alright, so we got there. I hope well, I did get there, and then okay. I don't know what just happened, but we're good. So I hope this was generally pretty useful. It's been some kind of strange stuff, but what have we got here? Once it dragged into your scene, can you attach a particle system to a character while... Yeah, totally. So I'll be honest with you, I ran out of time tonight. One of the things I was going to do was attaching a particle system to a character and then dissolving him whenever he touches a surface, which is actually one of the videos that Alex just linked back then, I assume. Yep. You linked to the most recent one with Crunch? Yeah, great. So, you can do stuff like that because in the same way that we can sample textures, we can actually sample meshes. And you can say, hey, put it on the mesh. But the cool thing is you can say, hey, sample the mesh and find out where on the texture it is. And you can then get that color and reproject. One of the coolest things that I've seen recently was I saw someone reprojecting the model's position in space to look at the scene color to sample it, which is a really awesome idea I'd never considered. So they had this like dissolving effect based off the scene color. Anyway, there's cool stuff. And as I said, like Niagara is great, but it is a little scary, and doing your best to stick to the existing nodes while you're making stock standard stuff. Like if you want to get good with Niagara, make an explosion. Don't start with explosion. Start by trying to remake something like my solar system galaxy universe thing. and then try and do something interesting with it. Maybe give it a collision, maybe give it some attraction to something. Then they take the next step to doing an explosion. So, can we get stuff flying out as a burst? Can we get them falling over time, etc., etc., etc.? Once you've got that going, hopefully after you've made a couple of effects, you have a slightly better idea about how approaching some of these problems. And you can start moving on to some of the stupid stuff like I just did. I point over my shoulder like I've got the thing sitting behind me. I do not. But hopefully that was useful for folks. What are some general things you find in other programs that we should avoid in UE? For example, can undo corrupt your file? Generally, I mean, the main thing that you might do in other programs that you should generally try and avoid in UE is obviously just like don't smash in 8K textures all the time. It's just general real-time issues, right? Like, you can use 8K textures, especially now that Unreal's got virtual texture support, but still treat them as a sometimes thing. Don't go into Substance and just do a unique texture map for everything, like, and push out 8K roughness maps and things like that for an object that's going to sit in the background. Those kind of problems are generally going to be where you run into some issues from existing workflows.
The biggest one I will say that I see quite regularly is don't delete objects outside of UE. So if you go into Windows Explorer, don't delete stuff there. Delete them inside UE from the content browser.
Yeah. Where possible, try and do stuff from UE. One of the questions came up was off topic, but how do you want us to demonstrate the ability to deliver our projects by deadline? That's a really good question. It's probably more of a Tony question, but he's not here, so I'm going to do my best to answer what, full caveat, this is what I personally would do in that situation. What I would personally do is I would try and relate the team back to any existing stuff that they had done. So if you're like, look, we think we can do this, and we've done this kind of stuff before, so that demonstrates that we know 3D space, or we know something else. I mean, you might have existing experience in another real-time engine, for instance. Like if your background is in Godot or your background is in Unity or something else, and you're like, hey, we want to take these skills and now just move it over to Unreal. I mean, we're not gonna like shake our finger at you and be like, whew, can't believe you did that in something else before you used our tools. I mean, like at the end of the day, understanding 3D space and understanding real-time is just super important, and that. If you're able to say, hey, we've done this to begin with, and we know this type of stuff to begin with, this is what we're doing now, then that's probably a good pitch. Now, if you have no background whatsoever and you don't have anything on that front, I understand that's a difficult position. So my suggestion would be just any of the early types of prototypes or demos or any of the learning courses that you potentially do on Learn, the learn.unrealengine.com would probably be good. I mean, just wherever possible, if you're able to back up, if you can't back up I know Unreal, at least do your best to back up I know 3D space, and I know I know that I can transfer this kind of stuff. And if you can tie that in with certain, even one or two elegant spiked out things, that would probably be still a good initial step for that application process. Because we know that it's going to take, there's a lot of beginners here, right? We know that's the case, but there's varying levels of beginners, and that's why we're also hoping that folks kind of find teams and work together. So if there's some people with experience here and some people experience with here, they're able to at least still put forward a reasonable enough pitch to say we think we can do this because look, we've made feature films before and we've invested ourselves in this kind of stuff, and this is us taking a thing. Or maybe it's we've worked in, I mean, we have several high quality portfolio pieces that we've used for other tasks, or we've made games, or we've made anything, I guess. I mean, it could be a traditional medium as well. Like there's a developer I know, and she's an extraordinarily capable tech artist these days. And it's funny because like when I first met her, her background was in sculpting and fine arts and such, and like she's able to take that general understanding of 3D space, even in a practical sense, and over time, like refine that into something digital. And I think that's really great. That was a really long answer, but hopefully that somewhat helped. Cool. Any other questions?
Can particles emit geometry?
Particles emit so I mean, you can do mesh particles, or do they mean mesh particles?
I assume that's
Yeah,
right.
so I mean, if you're talking about 3D objects, yeah. So there's a. Give me a sec, I'll find it.
I also dropped in a Twitter link from Ryan Brooks. He's really talented tech artist.
If you're going to link Brux, it's worth linking Jonathan Lindquist. It's worth linking Aaron Langmead. It's worth Joseph Azam. If you're going to start with one of us, mate, you better link all of us. And me?
Yeah,
What is this?
true.
Give me just a second. Sorry, I'm just opening up the content examples again to show you some of that stuff.
Also, this tweet in particular might answer someone's question, e.g. Luke's question about using sign distance fields and stuff with Niagara.
I mean, the sign distance fields is actually what I was going to be. Sign distance fields is how I was going to pull apart that character later on tonight, and that is in that video that I showed you earlier. So we're using the distance fields on that front. So this is the example project. It's worth noting that like there is just you can literally just add mesh renderers. So you can see here these arrows are 3D objects, and they're actually looking at color data of where they're going. So they're going from there, and they're being told to find a vertice on this mesh and change. So there's some cool stuff like that. As I said, there's some really kind of crazy effects. This is a really cool one to slowly get your head around, but I wouldn't start with that. I would definitely work my way up to it. So someone's asked about ocean sims. So interestingly, Unreal's. So some of the stuff that's coming in 4.26 is water and clouds, and they both look incredible. But the ocean sims and such are actually done using a Niagara 2D grid and combined with just Gerstner algos to kind of calculate where the splashes are and all that kind of stuff. That's pretty solid. It's not in the engine yet though, so it's up to you how you want to approach the problem. But yeah, Gerstner waves are definitely a really great starting point for that. It's just gradually putting in everyone's Twitter feeds as we go through.
I'm trying to find good examples, but there's a lot of retweets.
I feel like you're giving everyone but me, and I'm getting a little jealous. It's fine. Any other questions? Available in source. I mean, I don't use the source engine. Unless you mean source code. Oh, is the cloud and water available in source code?
In dev rendering.
Okay, that's where we're going. Okay, so if you're asking, I think it's in main. Yeah, I'm pretty sure it's in main. So if you want to download an unstable build, but still poke around with it, I have it on my machine, but I'm not sure if any of the other stuff in the project is allowed to be shown, so I'm gonna not pull that one out. Someone said, should I join Twitter? You know how they describe Mos Eisley? It's kind of how I feel about Twitter sometimes. But every now and then you come across a Han and Chewbacca situation, so that's also still pretty good. It's a mixed bag. I use Twitter a fair bit though. There's a solid games community on Twitter. Not too much on the film, but there's a solid games and VFX community on Twitter. So potentially, I'm not going to push anyone down that. Can you create a page with all these various links? Yeah, look, that's a good point. Look, what we'll do is, the box link that everyone's using to get around. We might update the box link with just some suggested community stuff for some of these sessions. I think we have a list of some of the links that we've put through. That's probably a good way to do this because it's like non-invasive. We don't have to hit 1,500 inboxes with updates and stuff like that. We'll see what we can do over the next couple of days. No, it's the weekend. We'll see what we can do early next week because I need to not look at Unreal for a couple of days. I'll be honest with you. It's been... it's been something. If you want to annoy Chris, it's always worth joining. That's Uh, what else? Thanks, folks. Are you expected to see animatics or storyboards have fleshed out an idea for the comp? Look, this is a really tricky one because it's going to come down to your relevant screen agency. It's going to come down to your relevant screen agency, but the trick you've got is like if your relevant screen agency doesn't have any terms about what they're looking to see, you're kind of going up against whatever anyone else pitches. So if you pitch just a treatment, but someone else pitches like portfolio work and examples and stuff, I mean, they're going to be taken into consideration differently. And like, I don't want to say that, oh, it'll then definitely be that one. Your pitch might be great and you might have enough to justify it, but I mean, it kind of comes down to whatever your screen agency specifically is accepting and whatever you feel is necessary to stay competitive, I guess, for lack of a better term on that front. Hopefully that would help. Someone said I should probably look at UE over the next couple of days. Okay. So is there a learning project I should look at for the Monday Tech Art stream? I'll be honest with you. The Tech Art stream on Monday is going to be some weird stuff. Sorry, Tuesday. It's Tuesday. It's definitely Tuesday. Yeah. Sorry, you said Monday, so I said Monday. The next sessions are on Tuesday. We have Monday off because I didn't want to hit up all 5 days of everyone's week for this stuff. My apologies. So yeah, it's Tuesday. But anyway, for the Tech Art stream on Tuesday, my advice would be, look, if you've generally had a bit of a peruse around the content examples, you've generally had a bit of a peruse around even marketplace content and just seeing how a world is set up, then that like the better of a general basic understanding you have of Unreal by the time the Tech Art session rolls around, the better. The Tech Art session it's going to be a lot of just cool stuff that you can do, but I'm actually going to be doing my best to really okay, sorry, I'll start this again. I'm a little bit scatterbrained tonight. I'm sorry. The best way I can sell the Tech Art session is there's a lot of stuff that people don't even realize they could do in a virtual environment. Basically, there's a lot of game effects that people look at and they're like, a wizard did it. And it's not that a wizard did it. It's just sometimes trigonometry in some weird and wonderful ways can just do stuff that you just don't expect. Or maybe just combining two different things that you didn't think would fit together originally will work. So it's going to be a lot of simpler stuff that's being like, hey, these tools exist and this is how this can do something cool. And then it's going to be a lot of more advanced stuff that's going to be like opening people's eyes, I guess, more than anything, to just something being feasible. Like, I mean, how many people in the chat would have been comfortable saying, yes, you could make a live hologram made up of like 5 million particles that are generating themselves from a cylinder, and the game or the real-time engine will still run at a solid 60 FPS and not care. A lot of people would have been like, no, that would be preposterous. But it actually does, So the Tech Art sessions, I'm going to be doing my best to just do stuff that's kind of cool, but also do stuff that just hopefully opens up some eyes a little bit. Yeah, and hopefully that goes all right. Was there any change in adding a quick run through of composure? So we're having a couple of discussions internally about what we could do that may help out some folks that are looking at doing compositing. The problem is that there's a lot of people doing compositing that is considered the right way, and a lot of people that are kind of hacking it together in some ways that aren't having the best possible effect. And to be blunt, because we're doing these webinars from home, I don't have an LED wall or something that I could comfortably do to do some of the stuff that we'd like to show off. So we're having some conversations at the moment to see if there is anything we could do during this training period to give people a bit more information. But I can't guarantee anything during this period at the moment. I'm sorry. Like it's this is the first time we've run a challenge like this, so I've done my best to generally give a reasonably well-rounded view of Unreal itself. Because I think, to be honest, when we went into this, we had a much higher expectation of folks taking an animated approach. And while we're not against doing film and compositing and that kind of stuff, I kind of set up the coursework more directed towards animation. And that's not to say that it has to then be an animation that's submitted by any means, but that's what kind of tailored a lot of the work that was coming out of my end. So we're seeing if there is anything. I just can't promise it at this time. Someone said, I would love to see any of the projects either of you are proud of working on. Today's 1.03 email. I mean, honestly, like, my work before Epic was predominantly UE3 stuff. And it's funny because, like, my skill set these days has not been developed from shipping as many games anymore, as much as it is, as I said, I fly around and I work with teams. So I'll end up on site with an animation studio for a couple of days, or I would end up at somewhere else, and it's a constant it's a job that is constantly solving problems, but the more I'm kind of like solving other people's problems, the better I start getting. But amusingly enough, if you were to look at my portfolio of the last like 4.5 years or whatever it is with Epic, it's just a dry spell, because it's literally just like the last several years is working on other people's stuff, but purely in like a day or two's assistance capacity. It's nothing that you would credit by any means. So it's kind of a funny situation to have ended up on. Yeah. So my apologies. I can't send any of the recent stuff through. But I mean, hopefully I've at least demonstrated in the last week that I generally know what I'm talking about, and you can trust me a bit. But yeah, look. So anyway, look. Thank you all very much for coming. I hope this session was useful. The next one's tech art, and then we're cycling through again now. It's worth noting that when we cycle through again, like, these sessions aren't pre-recorded, as demonstrated by, honestly, I screw up occasionally. But we're doing our best for the second cycle as well to try and iterate on some of the feedback that we've got, and doing our best to kind of like take in some of these changes into account. I didn't want to run this training as just hitting play and letting everyone watch a video at a certain time of day. I wanted this to be more of a discussion and something that we could evolve. So yeah, that if you were uncomfortable with any of those areas, potentially a second viewing that you're able to ask questions now that you've kind of mulled it over a bit could be useful. Yeah, by all means, don't just expect the exact same thing. It'll be close, but yeah, there are definitely going to be some changes. Like interior environments, I'm definitely making a couple of changes to. There's a few things I'd like to do in outdoor, like I'd like to get some better examples of water and things together for people. So just across the board, there's just little stuff because of your questions and feedback in these first several that so hopefully a bit more useful. Thanks for the real-time tutorials. Okay, well look, have a good weekend, everybody, and hopefully I see some of you back on Tuesday for the tech art and potentially the next round. Again, do me a favor, and if there's any folks that you think of that might be interested in this, you don't mind having a bit more competition, please spread the word, because we're keen to have as many people jumping in on these sessions as we can. Yeah, I'm excited to see what everyone makes. Have a good weekend, folks. Take care.
Enjoy.
Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. watching the lightning coming alive.